Hey everyone, welcome back. Today I want to make a tutorial to go over our Milestone 2 where we discover blocks and configurations. This project milestone will require you to practice how to do your SolidWorks extrudes, which include bosses and cuts, shell features, sketch relations, convert entities, linear feature patterns, equations, global variables, configurations. We'll also learn how to create derived parts and change the appearances of our parts. So this is for our off-roader. We are working with the LEGO Creator Kit 5761. So to begin, open up SolidWorks and we'll go to New Part Document. So you can just click this paper tab. If that's not on your toolbar, you can go to File and drop down to New, and this window will pop up. Go ahead and select your part document. So to begin, this project is broken up into two different parts, although it's the same milestone, just to kind of make your work a little easier and simplified. So we're going to create a part we call SkinnyBrick. And from this basic part, we're going to create the rest of our Lego pieces. So the SkinnyBrick is not an actual Lego piece in this kit. It's going to be a 6x2 white block, similar to your basic Lego blocks. It needs to be created in this order and following these directions. You'll then save it as SkinnyBrick in your project folder. So to begin, it wants us to create global variables, length and width, and set them to 6 millimeters and the width to 2 millimeters. So if you look at my part document window, you'll see that on the bottom toolbar, my window is in inches. So I'm going to select this up arrow and change that to millimeters. Now that the whole part document window is in millimeters, whenever I dimension anything, including inserting my global variables, I will not have to select what I want their units to be. It will save me a lot of work and a lot of time and make sure that my part is built correctly. If I were to leave it in inches, then when I go ahead and create these global variables, I could change their units just to millimeters. But you don't want to have to do that to all your dimensions if you don't have to. So make sure you start with a brand new part document window. Make sure your units are correct. You want to build your Lego pieces in millimeters because they're so small. You don't want to have to convert or use tiny inches to do that. So to begin, let's go over and we'll go to our toolbar. Go to Tools and down to Equations. You'll see our Equations, Global Variables, and Dimension window pop up. So we are only going to add in global variables. The rest of these will come up as we use our global variables or create equations in our sketch, in our feature, in our whole part document. So you don't need to mess with them. So just click Add Global Variable. I'm going to start with length. So you'll see it's red, but as I tab over, it stays red but adds in quotation marks. This is not a function you have to put in. So it's not like a computer science course. You'll have to do a little bit of coding, like just making sure you're using equals correctly in your parentheses, but it's very simplified. So SolidWorks automatically will put these quotes in. Once I tab over, I can type in my value. So I want this one to be 6. If I had my part document window still in inches, then I'd have to come to units and select millimeters, but since my whole window is in millimeters, I can just hit enter. Make sure it doesn't change it to 60. And you can see it evaluates it to 6 millimeters. Once you hit enter, another row will pop up. So let's add in width, tab over, and this one's going to be 2. I'm going to hit enter again. So I have my length and my width and 2. And now I can hit OK. I don't need to make sure it's in millimeters because the whole window is in millimeters. Once you add in equations, you can see that you now have a new equation folder over here. You can hit the arrow and it will show you what your global variables are. The global variables will appear with a world-like icon. Instead of going over to tools and down to equations every time I want to change these or edit them, you can then just come over to the equations folder on your feature tree manager, right click and go to manage equations. Then I could change them here. So let's go on to step 2 in our project. So now we want to create a base extrude feature from a rectangular sketch where the length and width are defined using an equation referencing our two global variables. We also want to multiply them by 8 to calculate the total width and length of the block. We want to place our sketch on the top plane, and we want to make sure our base feature is extruded up to 3.2 millimeters. So since we're working on the top plane, I'm going to go ahead and select that top plane. All these 4 icons pop up. This one that's like a paper with an arrow pointing up is our normal 2. It's much easier to sketch on something if you're looking straight or perpendicular to it. So go ahead and select that normal 2, and you'll notice that your top plane then comes perpendicular to your view. So let's go ahead and we'll open up a sketch. Select your corner rectangle sketch, since we are just going to have a basic rectangle for the base of our Lego piece. Remember, you need to sketch from the origin. If you do not connect your sketch to the origin, you are floating in space. You're not connected anywhere. So when you make this a 3D part, it will never be fully defined, or even your sketch won't be fully defined. You can see on this bottom toolbar, it's under define and I'm editing the sketch. Because you need to be connected to your origin, your datum. You need a place in space where you are connected. When you get multiple pieces together and start creating your Lego assembly and you want to make it move, if you're not connected to an origin, none of your parts will move because it will just move the whole assembly around. So make sure you always sketch from the origin. So I'm just going to left click and bring out my rectangle. Now I'm going to smart dimension that. So once again, click the smart dimension tool. Go ahead and grab that line segment. Make sure you're not grabbing at the midpoint. That will just make things a little more complicated. I do want to point out these relationships that SolidWorks put in automatically came up since I am using the rectangle sketch icon. So I have 2 vertical line segments and 2 horizontal line segments with the relationships. So that will save me some time because now I don't have to put those in. Also, since I'm hooked to the midpoint, I do have this coincident relationship added in as well. So select your line segment and then left click. Now to modify this, we want to use our global equations. So to use your global equations, you have to select the equal sign. So go ahead and put the equal sign in. Then you'll see a global variables tab pop up. Go over and select length. Now in our instructions, it wanted us to use our equations, but also multiply them by 8. So I'm going to type in my multiply sign. See, I'm not using any parentheses. And 8. And then hit OK. So you'll see that we were successful using our global variables because the summation sign will appear before our dimension. If I just had a basic dimension, like for example right here, there's no summation sign. Having the 2 dimensions would make your sketch fully defined. But when I go in to change my global variables, the great part about the summation sign is it will change the overall length, width, all your features if you've connected them with equations and global variables. If you do not have the summation sign, make sure you go back in, select that equals sign. Without the equal sign, you won't be able to use your global variable function. Then I'm going to select width here. Remember to put in your multiply sign by 8 as well. Then hit your green check mark. Then I'm going to hit the green check mark here to get out of my smart dimension. I'm going to double click the roller on my mouse just so I can zoom in a little bit. But now you can see both of these dimensions have the summation sign. You can double click if you want to see it, and it will have length multiplied by 8. So demonstration now is if I went over here to my equations tab, went to manage equations, and say I changed the 2 to be 6 as well, and then hit OK, my sketch is going to jump up, and that 6 now is multiplied by 8, creating a square of 48 by 48 millimeters. So go back to your equations, manage equations, change our width back to 2 because we want to build our basic brick first, and hit OK. So now it does want us to extrude, so go over to your Features tab, select Extruded Bosch/Base. We can leave the direction blind. It is coming up. Remember, we wanted our extrude to be up, and our distance down here, we're going to change to 3.2. This is going to be the basic overall thickness of your Lego blocks. So if you get lost, you can go back to this tutorial or this milestone and see what your basic dimensions are for most of your bricks, because they're all going to have to be shelled the same. The knobs all have to be the same diameter and height so they all fit together smoothly. So now we're on step 3. We want to create one circular knob feature with a diameter of 5 millimeters and a height of 1.8 millimeters. We want to locate the center of this boss 4 millimeters in each direction from the corner of the base feature. So our base feature is the first part feature we make. So this basic rectangle is our base feature. So since I want my knob on this plane on the top of my base feature, I'm going to select this top face. You can see that it will highlight in blue. Once I left clicked on it, all these icons come up. These are your shortcuts. Go to that normal 2 icon again, the paper with the arrow pointing up, and select it. Now that plane is perpendicular to my view. I'm now going to come over here and on my toolbar and select the Sketch tab. I'm going to open up a sketch, and this time I'm going to select my circle icon. I'm just going to leave the circle type where I have to put in a midpoint, and then I'll do a diameter and kind of do it in this general area. Once you create the sketch, just select your smart dimension, grab that outside line edge, and we're going to put in our diameter, which is a 5 millimeters, so just hit 5. Remember, you don't have to change the units since the whole part document window is in millimeters, and hit OK. So you can see it's still blue because it's not fully defined. We can still move this sketch around. So now I want to smart dimension and put its placeholder. Remember, a feature is going to need its size plus at least 2 dimensions on where it's going to be placed. So we're going to select the midpoint in this top edge, and these are going to be 4 millimeters in each direction. So go ahead and put 4 and hit OK or enter. Now I need to dimension it from the midpoint to the side edge. So select midpoint, your side edge. I'll bring that dimension up top here so you can see them clearly. Go ahead again and hit 4 and hit OK. You'll see that now, because we have this feature fully dimensioned, that is now went in and it's fully defined. It's all black. I can't move it around because it has its overall size and placement values as well. So now go back over to your Features tab. You can click Edit Exit Sketch or just stay in it since we are working in the same sketch. We're going to select the Extruded Bosch/Base. I'm going to hold my roller down and move my mouse around just so you can see where this extrude is coming from. If it was going behind your feature, it would just go up to the next face or however far. So if you're having this issue, go under the direction 1 under your feature tree manager and just click these arrows to reverse your direction. So you can see exactly where it's going to come. I'm going to go ahead and change this depth to 1.8. Then hit OK and then check mark. So now we have our first knob feature on our Lego piece. Let's go to step 4. We're now going to create a linear feature pattern using the edges of our base feature to define the direction. We want to set our spacing to 8 millimeters and set the number of instances in each direction by using our global variables. So once again, I'm going to select this face just so it's a little easier to draw on, and hit normal too. So now I'm going to come up here under my Features tab. I'm going to go over to Linear Pattern. Select this icon. Now I need to choose my direction. So just start at the top of your feature tree manager and work your way down. So what's highlighted is direction 1. So I'm going to start with the length. So you're just going to select this edge. I can turn my piece and you can see just that top edge is selected. That's going to be the direction 1. The distance is 8 millimeters. And then for my number of instances, it wanted us to refer to our global variables. So to do that, you need to select equals to. Your global variables will pop up. We're going to select length since this is the edge I selected first. Now it will make sure we have 8 millimeters between each knob that is built, and the length will change according to how big our brick gets and their spacing. Because since we are 4 millimeters from this edge to the midpoint, it will be 8 millimeters to the next midpoint, and so on. Now we need to select our direction 2. I'm going to select this side edge. You can see this arrow is going the wrong direction, so you can double click it here or change the direction right here. Since my first knob or instance is at the top, I want to make sure my arrows are going away from it in the rest of the space of my Lego piece. So that top edge, the arrow is going off to the right. On this side edge, we want our arrow going down. So once again, I'm just going to work my way down my feature tree manager. I'm going to change this distance to 8 millimeters. And then right here, I'm going to set my instances to equals, select global variables again, and this time we're going to use the width. And it's going to be the same as well. It's going to just repeat this feature as our part grows. Now I don't want to select pattern seed only because I want this pattern to go on and on. With the pattern seed only, it would only select 1 and create 2 more. So you'd have 3 total with the right spacing. So leave that unchecked. Next, you need to select what's your feature you want to repeat. So in this icon, you can click on it right here in your sketch. You can have a preview. If your preview is not coming up, just scroll down and you'll see options and you can select a full preview or partial. If you're not able to select that feature or sketch, you can come up to the top and you'll see the side arrow with the name of your part. Go ahead and select it, and then you'll have a drop-down menu of your feature tree manager and you can click that feature. Once you see this, go ahead and click OK. So now you can see we have the whole top of our brick created. We have all those knobs nicely distributed, and you didn't have to create each single feature. So our linear pattern features, they're one of my favorite just because you don't have to make every little feature. It automatically spaces it correctly, so you don't have to calculate that. It saves so much time. And now that we used our global variables within our instances in both of those, whenever I change the main global variable, all the knobs will fill up the space fully. So right now I'm going to go ahead and save my part. You want to always save often, especially when you're dealing with a lot of parts in like an assembly, because since your parts in SolidWorks are so huge, sometimes the program can just shut down a little bit. So I want to save this, go to File, Save As, and I'm going to call it, I'm just going to save it to my desktop right now, and I'm going to call it my SkinnyBrick. You don't need to change the file type. Since it's a part, it will automatically save with the right file extension. Then just hit save. Okay, we're now going to start by creating our features underneath. This is going to be step 6 in this project. So go ahead, hold the roller on your mouse down, select that bottom face, and hit normal 2 so we can sketch directly onto it. So to begin, we want to, this is step 5. We want to use the shell command to create a shell feature with a thickness value of 1.5. So since I already have the face selected I want to work on, you can see it's only the bottom face. I'm going to stay under my Features tab, and now I'm going to come over to the shell icon. Go ahead and select it. You can see that I need to put in a depth, so we wanted this value or dimension, we wanted this value to be 1.5. The cool thing about the shell feature is it will shell the entire material, so that wall thickness that is left will be 1.5 everywhere. This includes inside the knobs if we go too deep. So there's a tricky step here because we need a certain depth from our Lego piece, but we can't use the shell feature the whole time because we'll shell out too much material from our top knobs and they'll go away. Or SolidWorks won't let you do that because you won't have any material left. So make sure you're following the project step by step. So go ahead, select your dimension of 1.5. You can see your face is already highlighted. If you did not click this face, go ahead and click it now, then hit OK. Now you can see this wall thickness right here is equal all the way around. It is 1.5. If I were to measure the thickness in my knobs now, it would also be 1.5. So you can kind of see they've been extruded as well. You have that 1.5 material left around each of them and the edge. To show this view, I just came up to my display style and changed it to hidden lines with visible edges, or make your hidden lines visible. I'm going to go back to shaded with edges so it's easier to see. Now here is the tricky part. So you'll see, we can see all the features we built in our feature tree manager. So we've created our shell of 1.5. Now we're going to go to step 6 where we need to adjust the depth of the hollow under your Lego by doing another extrude cut that is only 0.1 millimeters deep. This is going to be made from a rectangle sketch inside the shell base. This makes the depth, the overall depth, 1.8 millimeters instead of 1.7. This is so your Lego blocks will fit together properly without cutting out too much material in your knobs. If I made my shell feature, even if I just added 0.1, so I did it 1.6, too much material would be cut out from my knobs and we couldn't finish the feature or just cut the whole top off. So make sure you can hold your roller down and kind of turn your piece. You want to make sure you're sketching on this inner cut face. So you have to have the shell done to create the correct sketch. So I'm going to select this inner face. Now I'm telling you to use your mouse roller to turn your part so you can see it's selected. So when you bring it normal to, it looks like it could be this outer face edge as well. So you want to make sure you're just sketching on the inside shell face. So I'm going to come up here to my sketch icon or sketch tab, select sketch, and I need to select a rectangle sketch. Now you need to make sure your rectangle is connected to the endpoints inside that sketch. If it is not connected, you will have problems later on when we change our global variables, because your part will grow, but your underneath cut will only stay this size that you set now. It will not change with your part. So if you're connected to the edges, so I'm going to roll that around, you can see all my endpoints are connected to those bottom edges. Now when I change my global variables, it's going to change along with my entire block, and that's what we want. So go ahead and hit OK. We don't need to smart dimension it because it's the right dimension with all the edges. Even though it appears blue right now, it's just because we have it selected. On the bottom toolbar, it will read fully defined. because that length and the relationships are put in by what we already are using. Next, I'm going to come over to my Features tab, and now I want to do an extruded cut to make that depth a little deeper. So come over to your extruded cut icon. Make sure you're not doing an extruded base feature. Select that extruded cut. You can change your direction to blind if you'd like, because we're just going to set the depth. Make sure if your cut's coming out from your sketch that you change or reverse the direction with your arrows right here. And we want to change it to only 0.1 millimeters. So I'm going to change it to 0.1. You can see it's just a very small sketch or cut, but it just brings that depth in a little deeper because we want our parts to fit flushly together. Then go ahead and hit OK. So if you're just looking at your part, it looks the same. 0.1 millimeters is very small. But on our feature tree manager, you can see that after the shell, there's now an extruded cut underneath as well. So this is a tricky step because a lot of time it will be forgotten. And now we're going to come up and we're going to use the Convert Entities tool. This also can be a little bit tricky as well. So for this, I'm going to select my underneath face because now we're going to create that underneath circle that goes right here. So select it and bring it normal too. To convert my entities, it's much easier if you change your display style. So I'm going to select my tab up here and go back to Hidden Lines Visible. You can see the outer lines of my knobs now are shown as hidden lines, so I can see exactly where they are. Okay, so now that you can see the bottom edge of all your parts, I'm on step 7. It says we're going to create a sketch on the underside, so that's the face we're on now. We're going to convert entities and bring the 4 outer circular edges of our bosses or knobs into our sketch. That's why we're using the hidden lines display style, because now you can see the outside edges of those knobs, where you need to bring 4 of them into this new sketch. So you're going to select those, make them construction geometry, and create an annulus, which is a circle within a circle that will be concentric on itself. And the outside circle will be tangent to the dashed lines. You only need 3 tangencies to define this outside circle. The inside circle has a diameter of 5 millimeters, and then we'll extrude this annulus up to the surface of our bottom face. So go ahead and go to your Sketch tab. Select this sketch icon because we need to open a new sketch. Select that inner face that we're going to be sketching on, and then under your Sketch tab, go to this Convert Entities icon. It will ask, what entities do you want to convert? This is where you're going to select these 4 outside edges of our knobs that are up top. Once they're all highlighted, go ahead and hit OK. You can see that it now brought those dimensions up to the face we want to sketch on. So now I just need to bring my part back normal to, so you can come up here and select the normal to icon. You can also just hit Control 8 as well if you're into the keyboard shortcuts. Since our sketch is already open, go ahead and select your circle icon. Place it as close to the middle as you think, and we're just going to place our larger circle. Since we are creating an annulus, it's a circle within a circle. We don't want to have to put in relationships extra if we don't have to. So to make this one concentric, they have to share the same midpoint. So I still have my circle sketch on. So go ahead and select that midpoint and create a circle within it. Then hit OK. Now, like the instructions said, we need to make this outside circle tangent to 3 of these circles or bottom edges that we converted. So since my sketch circles are there, I'm going to come over on my Sketch tab still to Display/Delete Relations. Click this down arrow and go to Add Relation. So I'm going to just delete the entities so we're starting fresh. So if nothing's selected, you want to select only the outside circle edge. And now I'm going to select this side edge. So I'm going to do these one at a time so you can see that the tangent relationship appears. Go ahead and select tangent, and now you can see that your circle got larger. Hit OK. Another shortcut to this is I can just select this outer edge, hold my control key on my keyboard down, and select the outer edge of now my second circle, and that same feature tree manager of the add relationship will pop up. You can see both the arcs I selected are there, and then you can hit tangent again. So I prefer using the keyboard for this instead of going all the way across the toolbar, but you can do either way. So as we've added in these relationships, you can hover on that over them, and both the edges and the relationship will pop up. So we are still not fully defined. We need to make our circle tangent to one more edge. So make sure you select the outer edge of your circle, hold control down, and I'm going to select the edge on this top circle. Hit tangent, then hit OK. Now our outer circle is fully defined. It has turned black because its size has been created by creating those tangent features with 3 of our edges that we used on our convert entities. It gives us that our inner circle has the dimension of, or diameter dimension of 5 millimeters. So go ahead and select your smart dimension icon, select that outer edge of that inner circle, and change it to 5. Then hit OK. I'm going to hit OK. So now you can see that has now went and gone into being a fully defined sketch as well. So now we need to extrude this up to this top or bottom face. So I'm going to go over to my Features tab. I'm going to select my extruded boss or base. I'm working my way down. I'm going to hold the roller down so I can see clearly what direction this is going to extrude out. My arrow is extruding it out towards the bottom, so I'm going to leave that. But now, instead of it in a distance, I'm going to select my direction, and I'm going to change this to up to surface. I'm going to select this bottom face. So now it's going to extrude only to this bottom face. I'm going to come down here to my selected contours and select only this outer edge and hit OK. So I wanted to show you, because I know when you're working on a part you can come up to problems. So you can see, I'm going to just change this display style back to shaded with edges, that my annulus did not come through. Instead, a whole knob extruded. So if this happens, you can go into your boss extrude, right click, and go up to this edit feature or your sketch. So I want to change my selected contour because my extrude is correct, like the length and distance I want it, because it's coming up to that bottom face. So select your contour, hit delete. You can come up here and select this arrow over, and you're able to select your face there. Or you can zoom in, and I'm doing that by rolling my roller on my mouse. So before I only selected this outer edge, so that whole extrude was being that whole diameter. I want only the material between my two circles because this is a hollow circle under our Lego pieces. So select it, and then you can see a preview of that annulus. Go ahead and hit OK. So now we have our bottom feature. That's what it should look like. It's just a thin material all the way around. I'm going to select my bottom face and hit normal too. And now I'm going to move on to step 8. So I have here, you'll notice that you don't have enough annulus bosses on your underside. We can fix this by creating another linear feature pattern. Now, the key to this is remembering what edges you used and what corner edge you started with your first linear pattern. Because if I use the opposite edges, then when my parts change and get bigger or smaller, only one of those features are going to change with it. The other one will have an error. So you need to make sure you're selecting the same sides and the same starting edge as well. So to see what edges, go ahead and select this linear pattern. So I can see that I started on this side, so my bottom feature is created on the right side. Make sure if you created this bottom annulus over on this side of your Lego piece that you redo it so now it's on the same side as the first knob you create on your top linear pattern. I'm going to just click into it and go to edit feature so I can see that I used this top edge and this side edge, and that those are highlighted when I roll around to the back. So for my bottom linear pattern, I'm going to need to use the same bottom edge and side edge as well. Now you can use the bottom edges. You don't have to actually select the same top edge. It just has to be on the same side and top or bottom. So exit out of that. Bring your bottom face normal to you. On your Features tab, go up to Linear Pattern. So for direction 1, I'm using my length. So I'm selecting this bottom edge. Make sure your arrow's going out and away. Now we need to change our instances in our design or our dimension here. So you'll notice that here we need to link it the same by using the length and width, but we also need to have an N1 approach because there's always going to be one less annulus or ring underneath in the direction compared to how many knobs are on the top. So for our instances, right here I'm going to select my equals to global variable, and I'm going to select length, but now I'm going to type in my minus sign 1 because it's going to be that length minus 1. I'm going to keep this 8mm distance, and then I'm going to move down here to direction 2. You can see this equation automatically pops up with the summation sign, so you know that it is put in correctly. So for direction 2, I'm going to select this inside top edge. Make sure your arrow is pointing up. For its instances, I'm going to hit equals to my global variable, which is width, minus 1. I'm going to keep its distance away from each other as 8 as well, because everything is equally spaced from each other. So working down my feature tree manager, I then come to my features or faces that I want to create the pattern with. So you can select this boss extrude feature from this popover toolbar, or you can just click it on your underneath annulus or cut. I'm just going to select it to make sure all of it's selected. You can see a preview of what your pattern will look like. Everything's evenly spaced, and go ahead and hit OK. So now our part looks like a Lego part. It is built. It is beautiful. So let's play with it. So if I go to my equations, because everything is referencing my global variables, I'm going to right click and go to Manage Equations. I'm going to change the length to 10, and I'll change the width to 4. Then just hit OK. You'll be able to notice all the equations I used. It shows what my equations were and where they're located in my patterns or my sketches. So you don't need to change anything here. It will just show you. If I were to delete one of these will become red, and then you can just erase them. And then hit OK. If you have no errors pop up, and your Lego piece now has gotten way larger, but your knobs are still covering the whole top of your piece, go ahead, roll it on the back. Make sure those underneath circular annuluses are covering the entire piece as well. That extrude cut you had to make inside your shell face has gone the whole width. If you did not connect to your edges, then your extrude cut will only remain in one area. So you'll need to just go back in to that extrude cut and edit that sketch and make sure you stay connected to those features. Hit OK. Since this works correctly and I'm able to change my equations, I'm going to go back to manage equations, change them to what they were to begin with. So 6 and then 2. Hit OK. It snaps back still with no errors. I'm now going to set up my material. So click on your material, right click and go to Edit Material. Since these are Lego pieces, I'm going to scroll down to Plastic. Select your plastic, and I'm just going to select ABS plastic. And hit Apply. Now close. So now you can see I have an Equations tab. You can close that if you don't want to see what your global variables are. I now have my material selected as ABS plastic, and it has turned it to white. Since I want my SkinnyBrick to be white, I'm going to go ahead and save it here. If you wanted to change the color, you could select anywhere on it. Come up to this color wheel for appearance, click on it. Now if you want to only change the color of one face, you can click the face, an extrude, the whole body. Since I want to change the whole part, I'm going to select the whole part. But you are able to just make changes to one piece. So my part went gray. I can also choose different decals and scenes according to the plastic I chose. I don't care too much about the actual look right now because we're just doing a basic beginner SolidWorks course, but I do want to change my part to be white. So I'm going to select white. I'm going to scroll down, and because part 2 tutorial for this project, I'm going to change my Lego pieces to be the colors they are in our kit. I'm going to select this display state. All display states would change all of our parts. Eventually we'll have more than just this one. So this display state will keep it so it's only this part we've created. Then hit OK. So it kind of appears gray, but it is a white color. Hard to see. You can double check by selecting your color wheel. We do have white. If I wanted it purple, I could change it. So I'm going to just leave it white and remember to save. So there you have it. Here's our SkinnyBrick. This is for our Milestone2 Part 1. So stay tuned for the second video to finish up Part 2, where we will create configurations. We'll create 4 or 5 different Lego bricks within this one part file. So instead of turning in 6 part files, we'll turn in 1 part file, and it will have 7 different pieces total in it. And then we'll also create some parent derivative or derived parts as well. So stay tuned for that, and this is where our Lego creation begins.